Seeing What We Hear, An Eye to Help the Ear. This was the title of a recent editorial in a reputed medical journal, Respirology, published in May 2015. The entire editorial focused on the new findings of a collaborative research between Indian Institute of Technology Kharagpur and Institute of Pulmocare and Research Kolkata. The work was related to seeing something that we hear, rather cannot hear well enough. Human listening ability that can distinguish the voice of a crow from the voice of a cuckoo goes beyond appreciation of pleasant and unpleasant sound in our external environment. The invention of stethoscope in 1816 showed its great potential in medical field. Auscultation, that is listening to internal sounds of the body usually through stethoscope, became an important component of clinical examination. Physicians, through training, started developing specific skills to distinguish normal and abnormal body generated sounds, especially those of heart and lung sounds. However, there is an element of subjectivity in appreciation of stethoscope sound due to variation and deterioration of individuals' listening ability. Also, the expertise required to distinguish such sounds that come through professional training may not be available everywhere, more particularly in our rural backyard. The researchers at IPCR and IIT Kharagpur, through a collaboration, started investigating how the correlation between lung mechanics, normal or abnormal, and acoustic indices could be put in an alternate form of representation that is easier to comprehend and would be useful for diagnostic purpose. The target was to identify certain patterns in the sound which carry distinguishing signatures of normality or abnormality and present it in a visual form for easier identification of the same. For this, lung sound was collected from two groups of people during inspiration and expiration. One group belonged to normal and the other group had a specific lung disease. Advanced digital signal processing and feature extraction algorithms were used to identify distinctive characteristics of these two kinds of signals. A mapping algorithm was developed to convert the digitally processed lung sound into pictures that highlight these distinguishing features. It was found that, in spite of subject to subject variability in data collection, these pictures were representative enough to separate normality from abnormality, and the same was verified by three independent physicians. A corollary of this exercise was that when these pictures were presented to three independent laymen, they too could differentiate one kind of signal from the other. The researchers feel that the work has the potential in filling up the much felt gap of lack of quality healthcare facilities in remote places. Editors of the Respirology journal, in explaining why they are excited about this work and why it became the topic of the editorial, said the following: the study is novel in more than one way. It is novel in the aspects of sound that were chosen for analysis. It is novel, at least for us as physicians, in its visual representation of sound. The struggle to convert sound into images could be considered as Herculean as the struggle to convert language into a written form, and the authors have presented an interpretable pictorial display of their data.